Now, the topic we want to consider today is factorization of algebraic expression. Factorization of algebraic expression. Now, what is factorization? Factorization is an aspect of mathematics that deals with splitting a bigger expression into a smaller terms. Splitting a bigger expression into a smaller terms. That means factorization is a reverse of expansion. What we mean by this is that the journey traveled by expansion is being returned by factorization. Now let us look at some of the examples that we have here. Example 1. We are asked to expand 2 into brackets 3x plus 5. This is an expansion, and the result we are going to obtain from expansion will be returned by factorization. Let's look at it now. If we have 2x into bracket 2x into bracket 3x plus 5, what we are going to do now is that we are going to say we are going to make use of this 2x to open this door. This is the appropriate key that we are going to use to open this door. So that means we are going to say plus times plus, it gives us plus. 2 times 3, it gives us 6. X times s gives us s squared. Now the key is true with the first term. Now we want to proceed to the second term that is inside the room. 2x times 5, it gives us 10x. So the result of the expansion of this is what gives us this. Now let's check the correct option. The correct option is going to be option B. Option B is the correct option. Now let us see how we can now return the journey travel by the expansion using factorization. Now here is question 1b. Factorize 6s squared plus 10x. Factorize 6s squared plus 10x. Here are the options. For us to be able to solve this problem, what do we do? 1a. This is 1a. Then for us to solve the problem of 1b, we are going to have something like this. We have 6x squared. Then we have 10x. So here is what we are going to have. Look at what we have here. This is plus 10x, and then here is also plus. Then we look at what is common in between 6s squared and 10s. What is common? We can say first and foremost 2 is common to both of them. Now since 2 can go in 6, how many times? That's going to be 3x squared. Then this same 2 can go in this one. How many times? That is 5x. Is there any other terms that is common to this and this? Now we see x is also common. X is here, x is here. And so x goes here, we have 3x. And x goes here, we have 5x. That is going to be 5. X goes in this one, is going to be 5. So this is plus 5, and here is also plus. So what we have outside here is the key. This is the key. So we are now going to have the result to be 2x, that is 2 times x, that gives us 2x, into bracket this plus this, that is 3x plus 5. If you watch the result obtained by this factorization, this is the question that expansion started with. So the journey took, or the journey traveled by expansion, is now being returned by factorization. I want to believe it's very clear to everybody. We want to look at example 2. Here the question says expand minus 2p into bracket 4p minus 9, close the bracket, plus 8. P times p, that is p squared. Now again we proceed. Minus times minus, it gives us plus. Because when minus and minus, when they fight, no one will agree to accept defeat until when plus come and settle the dispute for the two of them. That is why we say minus times minus, it is plus. 2 times 9, that is 18. That is 2p times 9, that gives us 18p. So here is the result of the expansion. And when we check the option that is correct, the most appropriate option here is option B. Now, we have already said that the journey traveled by expansion is going to be returned by factorization. Let's see. Factorize minus 8p squared plus 18p. For us to solve this B part of number 2, the B part of number 2, we are going to have what we call minus 8p. We'll take this term, minus 8p squared, then we'll also take plus 18p. So we have a vertical line being drawn in between them. Now we're going to see, want to try to bring out the key that was introduced inside the room. Now let us first of all look at it. This is minus. We'll bring it out, because when minus times minus, then the result is going to be 8p squared. So we have been able to bring out the first key, which is minus. Then minus times plus, it gives us minus 18p. Let's look at it again. When you bring out this minus as one of the key, you bring it outside. Then you are going to say minus times minus, it gives us plus. Minus times plus, it gives us minus. Now, let's proceed. We'll look at it again. Is there any other terms, any other factor that is common in between here and here? We can say 2 is common. We take 2. 2 goes in this. That is 4p squared. 2 goes in this. That is minus 9p. Then again, is there any other thing that is still common in between them? We notice 2 is no longer common, 4 is not common, 3 is not common. The only thing that is still common is letter P. Now, P goes here. P goes inside here. That is, we are going to have 4P. Then P goes inside here. We are going to have minus 9. When we say P goes inside here, that means we are saying 4p squared divided by p. We're using this p to divide the terms that is inside this place. So when we say p goes, it means p being this 4p squared being divided by p, you have 4p. Then minus 9p being divided by p, we have minus 9. So the result of this, these are the key now already extracted. Then we are going to bring them together. 2 times p times minus, it gives us minus 2p. Then into bracket what? 4p. Then minus 9. Close the bracket. We see the correct option here is option C. That is to say that the journey travel all the way from expansion is being returned by factorization. The journey from here to here, and from here again is now being returned to expansion again, and that is what we have here. That is the beauty of factorization. Quickly look at example 3. Example 3 says expand bracket open k minus 3 bracket close bracket open again 2k minus 5 bracket close, and here are the options. Now, how do we go about this? If you can remember, this is geometrical function of algebraic expression, a situation where you have up to 2 different terms interacting with a single expression, or 2 different keys being used to open just a single door. That is an example of geometrical function of algebraic expression. Now let us see how we can solve this problem. Here we are going to have k minus 3, bracket open and close, terms, that is to say k having an interaction with 2k minus 5. That is the first key interacting with the first expression in an attempt to open this room. Now we'll take the second key also, which is minus 3, to still open that same room. That means you have 2k minus 5. This is what we have here. By the time we get to this point, we're now going to say plus times plus, that is plus. K times 2k, it gives us 2k squared. K times plus times minus, it gives us minus. K times 5, it gives us 5k. So the first key is already true dealing with the first expression. This is the door and this is the room. So the interaction is true with the first key. Now I want to proceed with the interaction of the room with the second key. Here we have minus times plus, it gives us minus. 3 times 2k, it gives us 6k. I believe we are following. Okay, that's good. Now minus times minus, it gives us plus. That is to say, when minus and minus fight, no one will agree to accept defeat until when plus comes to settle the top. Then minus times minus is plus. 3 times 5, that is going to be 15. Then we are now going to proceed and said, how do we unite this term and this term together? Because they look alike, they are like terms. This and this term and this term, they are like. It's different from this one. So we are going to connect this term and this term together. It will now become 2k squared minus 5k minus 6k. This one implies that I am owing 5k, then I'm still owing another person 6k. That means altogether the amount of money that I'm owing is going to be minus 11k. Minus has to be there to indicate that that is the amount of money I am owing. Here is now going to be plus 15 here. So this is the result. Now let's see which of the option is most appropriate. Option A wrong, option B wrong, option C is the most appropriate. Now we proceed to the second part of the question, which says factorize 2k squared minus 11k plus 15. The journey traveled by expansion is to be returned by factorization, and that is what is about to take place here. Now let us see how we can go about solving this problem. Here is B part, that is 3b, and this one is 3a. The 3b part of the question says we are to factorize 2k squared minus 11k plus 15. Please, I want us to listen attentively at this point. If you want to factorize this, the first thing you are going to do is that the sign here and the sign here, we're going to multiply them together, and that gives us plus. That is to say, plus times plus, it will give us plus. Then we are going to ask ourselves, what are the two signs I will multiply that will give me plus? Definitely minus times minus will give me plus, will be equal to plus. Is there any other thing that I'm going to multiply together that will give me plus? Then it will be plus times plus will equally give me plus. Now we're going to now proceed and say, try to duplicate the middle term, this middle term here. We want to double it so that it will be easy for them to be, it will be easy for us to pair them together. We pair this one with 1, then we pair this second one with the other one. But as it is now, we cannot do the pairing because they are not up to 4 different terms. So we want to double this particular middle term so that it will be easy for us to do the pairing. So we've started the process of pairing already. Minus times minus will give us plus. How did we go about that? We first of all say plus times plus. So what are the things, the two signs we are going to multiply that will give us plus? First, minus times minus will give us plus. Also, plus times plus will give us plus. Okay. By the time we add them together, which one will give us minus out of the two of them? Definitely this one can never give us minus. We cannot generate minus sign because see, there is a sign here which is minus. We need this minus to be part of the game. And so this one does not. We divide it by 2. And since we divide this one by 2, we multiply this one by 2. Whatever we use to divide this, we use it to multiply this. If we divide this one by 2, we multiply this one by 2. If we divide this one by 3, we multiply this one by 3. Now let's proceed. 2 divided by 2, we have 1. Don't forget, we are dealing with minus 1 and minus 1. So here is minus 1. Then 2 times plus 15, it gives us 30. So here is minus 1 and minus 1. If we put this and this together, if we simplify this and this, can it result to 11 minus 11? That is to say, if you say I'm owing minus 1 and I'm still owing minus 30, the result is going to be minus 31, which is not what is here. So we need the one that will give us what is inside here. So this one is not favorable. It does not fit in into this middle line. Now let's proceed. Let's use 3 now to divide any of these or these, because we have used 2 and 2 does not favor the game. Let's see how we can now use 3. Use 3 to divide this. It gives us 5. Use 3 to multiply this. It gives us 6. Now we're going to introduce those two signs again, which is minus and minus. We can now see from here that this one, if we say I am owing 6, owing somebody minus 6, I'm still owing another person minus 6, definitely altogether the amount of money I'm owing is going to be minus 11. That means this particular term, this particular factor is the most appropriate. This one and this one is not the most appropriate. So we can still proceed further, supposing we have not been able to get the most appropriate factor. After using 3 to divide this, if still we do not get the appropriate factor, we now say let's use 5 to divide it. We'll first of all use 2 to divide it. We divide the first one by 2, multiply the second one by 2. Then if that does not work, we divide the first one by 3, multiply the second one by 3. If it does not work, we divide the first one by 5, multiply the second one by 5. But fortunately, we have been able to get the most appropriate factor. Why this one is the most appropriate factor is because, first and foremost, when we say minus 6, I'm owing minus 6, I am still owing minus 5. Altogether, my debt, the amount of money I'm owing becomes minus 11, which is exactly what we have at the center. So we can now conveniently use this and this to occupy the center point. Thereby, we double the center point. Now let's proceed. We have 2k. That's going to give us 2k squared. Then minus 6k. Minus 5k. So we have been able to replace this middle minus 11k with double, and that is minus 6k minus 5k, which is still the same thing with what is here. Then we now put plus 15. Now our aim has been achieved. We can do the pairing. This and this can be paired together. We factorize. This and this can equally be paired together. We factorize. Now let us see how we are going to do the pairing. We are going to pair this and this. That is to say, we are going to say 2k squared minus 6k. This and this will be paired together. Then here we have minus 5k, then plus 15 will also be paired together. We are going to do the pairing this way. This one can be paired like this. Now let us see, because here the factorization begins from this point. What is common between here and here? We will take 2. 2 is common. So we have 2 goes here. That is, we are using 2 to divide here. It gives us k squared. Then using 2 to divide here, it gives us minus 3k. Is there any other thing again that is common between here and here? K is still common. So we take that k. We have k. This one divided by this k, it gives us k. Then this one, which is minus 3k divided by this, the same thing. All that we have been able to discover is that the journey traveled by expansion is always being returned by factorization. So we want to quickly proceed to example 4. Example 4. The question says, expand bracket open 2y minus 5 brackets close, and then bracket open again, y plus 4 bracket close. Here are the options. Let us see how we can first and foremost solve this problem. We are going to say 2. We will use this 2 as an appropriate key to open the door. Now let us have the question. We have y plus 4. We're going to use this. This is an example of geometrical function of algebraic expression. It involves the use of 2 different terms to interact with a single expression. So let us see how we can make use of these 2 different terms and 2 different keys to interact with this single expression. What do we do? Here is going to be 2y into y plus 4. That is to say, this first key, we are going to use it to interact with the first room, that same room. Here is it. Then we take the second key, which is minus 5, to interact with that same room. The attempt is that we want to use this first key to open this door, the door to this room. And we're using the second key also to open the door into that same room. Here is what we now have. Plus times plus, it gives us plus. 2y times y, it gives us 2y squared. We continue. Plus times plus again, we have plus. 2y times 4, it gives us 8y. So the first key has finished dealing with the room, the door, and then we have access to each of the 10 that are inside the room. Let's proceed with the second key. How this key can open the door and we can have access to each of the 10 that are inside the room here. Minus times plus, it becomes minus. 5 times y, we have 5y. Then we have minus times plus, it gives us minus it also. 5 times 4, it gives us 20. Now we can proceed this way. 2y squared. This term and this term, they are like, but they are not like with this one, because this one is power of 2, while this one is power of 1, power of 1. So the one that are having power of 1 can interact together. This is plus 5 plus 8y minus 5y, which means I have 8y with me and I'm owing minus 5y. So the person that I'm owing, when it comes, I will just, confidently dip my hand inside my pocket. I'll bring out 8 because it's my money. Plus 8 is my money. I count 5 and hand it over the person that I borrow this 5 from. So the money that will be left inside my pocket is going to be plus 3y. Then this minus 20 comes to stay here. Minus 20 come to stay here. Let's look at it again. Here is this times this, we have 2y, and then this times this, we have this. And then we proceed, this times this, we have minus 5y, and then this times this, we have this. So everything is now in order. I want to believe we understand. Now, we want to quickly go into the second part. The question says factorize 2y squared plus 3y minus 20. Here are the options. Please bear in mind that the journey traveled by expansion is about to be returned by factorization. And this is how we're going to go about it. Here is factorize 2y squared plus 3y minus 20, which is exactly what is here. The first thing we are going to do is to look at the sign here plus and the sign here minus. We multiply the two. By the time we multiply minus times plus, it will give us minus. It will give us minus. As soon as it gives us minus, then we are going to now think, what are the two signs that if we multiply, we add this and this together, that is plus 4 minus 10. It will give us minus 6. What I'm having here is not minus 6. So this one is not appropriate. So let's do the interchange. Minus 4 plus 10. If I work with this, I'm owing 4, I have 10. What is going to give me is plus 6. And what I have here is not plus 6. I'm looking for plus 3. So let's proceed. We've divided this one by 2. The result gives us this. We've divided this one by 2. The result gives us this. Now let us see how we can divide it by 3. It's not possible for us to divide any of them by 3. After 2, we have 3. Since it's not possible for us to divide any of them by 3, we move to 4. So let's divide this one by 4. If we divide this one by 4, we have minus 5. Multiply this one by 4, we have plus 8. This one that we arrive at here, if you watch, plus 8 minus 5. That means I have plus 8 with me. Then I'm owing 5. If I pay my money out of this, the leftover of the money that will be with me is going to be plus 3, which is exactly what we're looking for. So the most appropriate factor is this and this. The most appropriate factor we can use to double the content here is plus 8 and minus 5. We can now proceed. I said this most appropriate factor, we want to use it now. How do we use it? Let's see the way we are going to adopt it. Since none of all these ones is correct, we are going to clean them up. So the only one that is most appropriate is minus 5 and plus 8. It will become 2y squared plus 8y, then minus 5y minus 20. So at this point, we can now do the pairing properly. This and this can be paired. Then this and this can equally be paired. We are going to have 2y squared being paired with 8y. Then minus 5y being paired with minus 20. Then we proceed. What is common between here and here? 2 is common. So we have, when we use 2 to divide this one, we have y squared. When we use this 2 to divide this one, we have plus 4. Y. What else again is common? Y is equally common. So when we divide this one by y, we have y. We divide this one by y, we have plus 4. So we proceed to this one. What is common here? We first of all pick minus, because we don't want minus to begin a process. So we have to see how we're going to take this minus away from here. So we have taken minus. Minus times minus gives us plus. So we have 5y. Then minus times minus here again, we have plus 4 plus 20. So what s again is common? 5 is common. We take 5. 5 goes here, we have y. 5 goes here, we have 4. You can see we have been able to extract a key that was once used to open the door here. We have extracted the key. The key is minus 5. Here also, we have been able to extract the key that was once used to open this door, and that the key is 2y. So we can now bring the keys, the key here and the key here, we bring it together. It gives us 2y, and the key here minus 5. We bring it together. Then we can pick any of these expressions. They are the same. We can pick them. It becomes y plus 4. So this is the final answer. You can see the journey traveled by expansion has been returned by factorization. That's the beauty of mathematics.